Well, had to do a thing. Let's try that again. Okay. Okay. Pretty sure that's a bot. Oh no, this is gonna need to get like hard stomped on. It's funny, I said like foot stomp in a meeting the other day, which is something I picked up from like the lawfare people, and they mean it to be like, I want to agree with you, and I think the person didn't understand what I meant and thought they meant that it was the opposite. Oh well. Oh well. That's all I gotta say about that. Okay, can we see it now? Yes, there it is, like bastard. Okay, we don't need that there anymore. Of course, like it would be nice if it. Hello? I hate this asshole. Sometimes sometimes all sorts of stuff, like this time that it'll like eventually load. Yeah, there it goes. Okay, so that's more like it. So hey Eli, you're like the one of I've got like 3 stream windows open right now. You're like the one chatter. I'm in the middle of I'm planning this thing. So this is actually like largely planning itself. I am. This tool is a thing called Sense Atlas, and it runs on top of a application server I call Intertwingler. And I am in the middle of designing the internal caching. So, but if you kind of get like a sense of what's going on here, like this is like a semi-hierarchical graph representation of like all of the issues in a particular thing. So if I go to the center here, this is like super rough right now. I have it like, it's more or less like what I'm like needing to do is like accrue like enough instance data so that I can sort of determine from there, like, okay, like what exactly, like how exactly is this thing going to even be? And so I've been working with this for a few months now. I got it online back in like May. And so what we're basically looking at is this sort of a conceptual framework that I came up with like eons ago. And the idea has to do with like this thing I call a specificity gradient, effectively, which is like similar to, if you're familiar with like Stewart Brand and like pace layers and that kind of stuff. But the idea is basically that there are a lot of concerns in any design problem, and like a design problem is not the same problem as an engineering problem. Like I consider a design problem to sort of have, like, you're trying to take like a million possibilities and whittle them down to exactly one artifact. And so this is what this is representing is effectively like an issue network for, in this case, this is the MVP for Intertwingler, and then if you want to see the other bastard, it's the Sense Atlas front end, which is for this tool itself. So Intertwingler is the application server. Sense Atlas is this thing that you're looking at, and it's running on top of it. Sense Atlas is like barely software. So like, thanks. Yeah, one of the, but you can sort of see like, this is like, this is the same algorithm as GraphViz or Mermaid or whatever. It's called a Sukiyama algorithm. I just stuck it in a radial layout and with hyperbolic geometry, so it gets like farther as there's more stuff. And the idea is like the stuff in the center is like usually pretty legible as far as like normal people are concerned, and then like as you get out into the weeds, there's like more and more stuff, and there's more and more details. And so like when you go into these, like you can kind of like recenter, like actually I don't know what some of these are. Oh yeah, okay. Those are old. The other thing too I haven't done is any kind of state representation. So like a lot of these things are resolved. So like prune them out or gray them out or whatever. I just haven't really decided how that's gonna play out quite yet. And then there's like other things too, like horizons and stuff like that. Like, so I came up with this eons ago. So so the architect Christopher Alexander, who's responsible for pattern language, wrote a bunch of other books, but one of the first ones he did was his PhD dissertation called Notes on the Synthesis of Form. And he's like, a design problem, the way you solve a complex problem is you break it into pieces, and then you do that recursively until you have a set of problems that are small enough to solve, and then you construct that all back up, and then you should have the complex problem solved at that point. And then the actual doctoral dissertation itself was about like how you do that. And effectively what he says is he's like, okay, you get all the issues and you put them in a graph, and then you apply like a hierarchical decomposition algorithm, like basically like a modularity or like a min cut algorithm. You just partition, 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 partition. And so that's cool. But the there was like this other thing called IBIS, so it's like issue-based information system, which was by a guy named Horst Riddle in the 70s. He's actually a contemporary of Alexander. They both taught at Berkeley at the same time together in the 70s. So there's like a weird overlap there that doesn't really get written up too much. But that's what this is. So this is a these like three elements or these three classes: issue, position, and argument. So like an issue is just like a thing in the world that you want something done about. A position is what you want, like a specific prescription of what to do. So here's something. Where are we here? This is super slow because it doesn't have like any internal caching, because that's like literally the thing that I'm working on. Anytime, buddy. So I've gone and I've written the cache, but I haven't like hooked it up to this yet. That was actually the part, that's sort of like what I'm reasoning out at the moment, is like, of all the ways I could do that, how am I going to do that? There we go, finally. Jesus, okay. So, this takes a while to, oh yeah, this is going to load up both. There's like a bunch of just indeterminacies, like it's really quite interesting because like coming from like a design background and having like rather than being like, oh, we're just going to iterate, like this project has like almost nothing to do that isn't data, like, and it's also like the data has to be real, like it can't be fake. So there's that aspect of it as well. But so you can see like we're on an issue. This has been moved to the center. Everything else has been moved off to the side. The center is, and you can see like I can like mouse over the neighbors or whatever. So this issue is, what does it say? Okay, even ordinary page gets with the graph state has not been changed can be slow, particularly the first time a user loads a generated resource. Well, we just saw that. So there are responses to this issue. So add appropriate cache control headers, enable caching, and then there's like implement internal caching, which is what we're doing. But let me see if I can, that's this guy. So add appropriate cache control headers and enable caching on the reverse proxy that is wrapping Sense Atlas. I tried that. So like that's like, okay, the green guys are like, what do you do about the red or the pink guys? And then you can have arguments that like support or oppose. In this case, it turns out to be a bug somewhere in the caching mechanism that causes templates to break when they return 304 not modified. Yeah. So I was just like, oh, I'll just put caching, and flip on caching in the remote proxy or reverse proxy that is actually putting this thing out on the internet. And something just like it would return 304, and then the cache would return like an empty body, and then but it would still have like the content length and stuff on it. So it would just be borked. And so that's just generally bad. So that's like why this argument opposes this thing. So that's why this is not a viable thing. So I'm going to try to find the implement internal caching. Is that you? No. So there's like still, there we go. So implementing internal caching. So this is actually all client-side XSLT and a little smatter of JavaScript. But so it turns out that back in August that Google in their infinite wisdom, well, there's they're So Chromium uses libxslt, libxml, and libxslt. They're one of their guys, their security guys, went and found like a whole schwack of like vulns in there in libxslt. So the Chromium guys are like, we need to rip this out. And so like InfoSec me says that is a totally sensible thing. But like web dev me says that like, screw you, what are you doing? Why are you nuking a freaking perfectly good standard that's been there, you know, on the books for 25 years? So needless to say, I'm a little bit on the torn side from this. But anyway, it looks like what they're doing is they're moving forward with it and they're trying to get rid of this this standard that I've been using since like 2001. And in this particular format, I've been using it. I've been using it to transform, do like super cheapo templating. Web templating, super lazy, because it's like all you got to, you know, for sticking the presentation markup on it or whatever, it's like ridiculously easy. So anyway, so they're taking that away, and so it turns out. So where are we here? So if I go back up the chain here, yes, so Google has in fact eliminated or committed to eliminating support for XSLT. So the answer to that is to obviously create a server-side XSLT transform. That doesn't take very long at all. But we were relying on browser cache to keep XSLT from being intolerably slow, which is what we are observing right now. Well, then the answer there is to implement internal caching. So like, this thing is slow because it's basically doing too much work. And it is like the server's doing too much work per request, and it's like, it's basically not, it's like it doesn't need to do all that work. But Intertrailer does not have internal caching, so so then the question is, okay, like how are we going to handle the cache entity bodies? Well, this was an idea that I had a while back, and I implemented it. Actually, I've implemented it more than once. Are we going? No, we're not. So the cache entity bodies, we want to implement the caching of generated representations against this thing called Store Digest, which is a thing that I made. It's a content addressable store. And so, actually, I think what I want to do is I want to move this. Response. This thing I don't really have like the best. Okay, so we can get rid of that. Okay. so internal caching. So you can see that there's like a bunch of stuff like there's a bunch of questions and there's a bunch of suggestions, there's a bunch of sort of like stuff that comes out of this. Then we implemented caching and generated representations against Store Digest. Well, does this count as done yet? I don't know. Well, that's actually done. One thing that I like, there's one kind of representation that I haven't sort of figured out yet, and that is like, so like you can see these like mintier guys are tasks, whereas the limier ones are just positions. So the positions are not necessarily actionable, and they're not even necessarily, even if they are actionable, they're not like necessarily to be actioned, or maybe they're just like a decision that you need to make. Like they're not like a thing that you put in your calendar. They're just sort of like, you know, what is the decision? What is this? This says we want to be unified into a big blob of storage. Okay, so that is extend Store Digest to include, yes. Okay, so that is done. I think this even says it's done. All right. Yes, okay, so that says, I don't remember when I started that, but that's another thing too, is like I don't, like one of the things that I want to be able to do eventually is like resolve like calendar objects or whatever. So it's like you put something in your calendar, they show up in Sans Alice, then you can map those to particular tasks. Okay. Interface to a plate bias. Don't really like how those are very close together like that. The math on this is so goofed, it's just not right. Okay, that is done. Now, I need to get back to, how are we going to do that? Does this implement internal caching? No, this must be implement internal caching. Yes. What's really quite interesting is how the dependencies become very clear, like what order you have to do stuff in, which is sort of important. So, question by, how are we going to represent the metadata? You know what to is, let's go back here. We can like also rearrange the graph too, so that private cache entries, like, that is not necessary to be attached to that. But like that's how it started out. Like that was where it lived. Okay. So implement internal caching. How do we get the metadata? This is where I need to be doing the work right now. So that's done. Put the crash entity. So another response to this is we want to actually make like a fast want to do that. Put the cache into a memory store, into like basically like a swappable or like into a dedicated store. Yeah, into a dedicated key value store. Now, do we do Redis? I mean, we could do Redis. But I think what we should do is make it pluggable. I think what we should do is I think if you were going to do like multiple machines, you might actually want to have like multiple intertwingler engines, and then you're going to have like, I don't know, that is a, anyway. And then even still, that's kind of what I'm thinking right now. And then with the value is just the hash identifier. Because the thing is like, where is that? Because the thing is about the RDF store, like I eventually wouldn't mind being able to stick everything in an RDF store, but the problem with that is, like cache entries are basically garbage. Like they're one up from garbage. They're just cache entries. And so like the thing is like what's gonna happen is there's gonna be like stuff like the plans that I have for the RDF store is like it would just be dumb, I think, because what's going to happen is it would just like keep accumulating like these like derelict like triples that say stuff about the cache entries, and they're just they'll just go and go and go, and I don't think that's very smart. So yeah. Just thinking. Okay. I'll give this a supporting argument. The supporting argument is a dedicated cache metadata store will be much more efficient in many ways than trying to use RDF. But also, like, another matter is that, like, nothing needs to see it. Like, nothing needs to see the cache entries, really, I don't think. Yeah, so let's just go back to that. It's like, also, say supported by it. It is unlikely that anything actually needs to interface. This, of course, is like famous last words. Cache metadata besides the cache engine itself. Most unlikely that anything actually, yes. Okay, so this is also opposes another guy. What's this? Yeah, put the cash in. Yeah. See how the math is messed up? Like these go for miles. Because like really what I need to do for this representation is I need to do like a force clustering or something. I need to do something that takes, like, because all I'm doing is I'm just taking the linear thing and I'm making it radial, and then I'm taking the linear geometry and I'm making it hyperbolic, and that's like all I'm doing. So I'm not actually, there's better ways to do this math. Anyway, you can kind of see at this point that, so the argument here is for this, but it's against that. So it supports this and it opposes that. So I think that the thing to do is to just make a dedicated cache. So I think the quick thing to do is I'm just going to make like an LMDB front end for that. And I might even just bash out like a quick and dirty one. Let me just check something here. No, okay, so I have to make a cache. Okay, whatever. So what else? Oh yeah, so need to find the unified blob storage. Implement internal caching. What is this? Oh, the unified blob. I think that was a goal. What's this? Yes. Yeah. I think I need to check. See, the thing that kind of sucks about this interface is you can't search yet, like, and I've noticed that. Actually, here, let me just put that down in the front end, because that's what I can do right now. Resolver. That's interesting. Surprised that there's no. What is this? Oh. What is that? That's actually done. There's a bunch of stuff that's like way done. It's been done for a while. So, oh yeah, I know. Okay, so a matter of, so we want to be able to use arbitrary, how would I put it? Like we want to be able to use arbitrary, so we want to use other URL schemes. So there are, I would say that an issue is that there are plenty of other URL schemes besides URN, UUID, and there are plenty of other URI schemes besides URN, UUID, and NI. Such as ARC or, I don't know, DOI. And I mean a bunch of other. They're durable. Maybe I want to turn that into a goal. Here, we want to be able to, what's this? Okay. Review. So this is actually done. This was done as of yesterday. I don't remember when this started though. It's all right. I'm actually really quite pleasantly surprised that my internet hasn't blown up on me yet. Okay, that's done. So is this the unified guy? Unified blob storage. How do we resolve? But it's not necessarily achieved by. Question, how do we resolve? Content addressable. Um, 6920 content addresses to HTTP or any for that matter. Incidentally, this is a specializes of. What did I say that one was? Plenty of durable. Yeah. We'll just put that address for this guy here. Just because. One thing that I really would love is a link preview thinger. But that's like, it's like, everything, it's like I've had to make Intertwingler from scratch, pretty much. Well, it's not like scratch, but it's pretty scratchy. And so it doesn't have a lot of things like you would have just off the shelf in like Rails or whatever. Okay. So, how do we resolve? That's that. So I want to say we want to overhaul the resolver so that it has general, that it has pluggable transformations. Whew. Durable and readable. I guess I'm going to say routable but dereferenceable, but I think routable is. Should I say dereferenceable? This is such a mouthful. Durable. Yeah. Nah, I'll just keep it. I don't know how I'm going to do that yet. That is going to be like an experimental coding thing, I think. I don't know why. See, this is the thing that bugs me about this layout, is it like it does that kind of a thing. Durable identifiers and routable addresses. What happens if a resource has more than one durable identifier? Create a hierarchy. Have the resolver. It's like. No. What am I doing? Create a configurable hierarchy of URI schemes. Hierarchy. It's weird that didn't show. So So that's like if you have a UUID, but then you have like a hash. Also like, I don't know. Maybe metadata. This is a subtask. Where are we at? Oh, we've been going for an hour. So I think that's actually good. I think that is resolved for now. I think I know sort of, I have an idea what to do. So I am going to shut her down.